So if you want to follow along, you can. We're going to make some cool stuff in Salt. You can run it. If you want the instructions on how to do that, you can go here and at least download Salt, which, let's see if we can break the network real quick. How's that sound? Cool? Lovely. How's everybody doing? Good? Perfect. About 2 hours ago, the air conditioner unit in my room started making this lovely beep. Just didn't stop. So that was lovely. But anywho, hopefully everybody saw that recently. I'm Wes. I am a Mac operations engineer at Square, and today my talk is configuration management with Salt, and we're going to try and do a quick 0 to hero, if that is okay with you. Who here has ever heard of Salt or Salt Stack? Knows what it is? Cool, that's awesome. Is anybody actually using it? Greg, nice. Yeah, sweet. 2 out of 75, not too bad. Yeah, maybe after this you will. No? Yeah. First things first, what is configuration management? To sum it up, it's the process of maintaining the configuration of a system in an automated fashion. It handles the control of things like files, users, services, which in the Mac's case would be launch daemons, and profiles. Defined configurations are normally stored in some variation of version control, and normally those are in some type of code, as you would do in version control, and it's responsible for making the necessary changes to a machine to put it in a desired state. So I'm sure everyone's wondering, great, we have another configuration management tool talk. Is this like the 17th one we have? So, sorry. So we decided to use this one, and I'll go over a little bit why we picked this one versus the other ones that are out there. So why we picked Salt? First and foremost, we gave a few of the popular ones out there a try. And we noticed that the barrier to entry was a little bit difficult. It either required a specific DSL or you had to code. Everything was code. So we have a bunch of younger folks that like to contribute to our team, and this was an easy way to get them going quickly. So there is no coding required if you don't want to. Everything is just YAML, which as some people say can be quite difficult with white spaces or whatnot. And another thing we liked is pretty much every single thing in Salt is easily extendable. So if you find an issue or a problem with one little module, you can easily duplicate that module and fix it, and boom, you're good to go. And writing custom modules and stuff in Salt, super easy. And the number one thing for us was it was Python, and you can easily get to the Python Objective-C bridge, which allows you to do some fun stuff with the native APIs on Mac OS. And the biggest thing is that it is not written in Ruby. Because really, does anybody actually like Ruby? Okay, that's what I thought. And then, so the fun thing about a lot of the other configuration management tools that are written in Ruby, if you want to do Objective-C stuff, you have to shell out to Python, then go back to Objective-C. So that's really efficient, or we could just do it natively. Okay, so what's the plan? What are we going to talk about? So first we're going to install Salt and configure it for master lists. We could do a master setup, but we'll keep it all local, make it nice and easy. Then we're going to go over some different vocabulary and modules. Different module types, so when I talk about certain things in Salt, you're not like, what the heck is that? And then we're going to write some simple states, and we're going to show you how to target them to specific machines. And then we'll get a little more advanced. We'll write some advanced states. And then we're going to have a lot of fun. And we're actually going to write some custom modules. Or I'll show you ones that like I've written that are super easy. And then we'll show you how to run those custom modules. And then we'll cover high states, which is, well, we'll get there. Well, let's go. Giddy up. So if you wanted to, you can download and install Salt either through the repo or if you have auto package, there's an auto package recipe for it because who doesn't love auto package recipes? Anybody being like, no, don't take that away? Good? Cool. And then I made a little Git repo for different steps and running different things with, so you don't have to like copy them out and type them down. They're just all there on your machine. And then to set it up, you just cd into the, change the directory into the salt PSU repo, and then copy the minion config after you've already installed it into etc salt minion. So that's where Salt's native minion config is. And then you can make the SRV repo, and then that's where we'll take all the source files, and that's the place where we'll serve the files to Salt. And all our different states and modules will be in there, and that's where Salt will look for them. Once you're done with that, you can stop the launch daemon and restart it. Cool. So, Salt terminology. Let's learn some new things. The first one is the Salt master, which is normally the server piece that would be responsible for serving the different files and instructions to minions and sending execution commands if you want. But in this case, we're masterless, so that doesn't necessarily matter. But the minion is what is your computer in this scenario. So normally you would have a master and then minions, which would be like other servers if you were doing this in a, like a server environment. But with clients and portable laptops, we'll do masterless. So no matter where you are, you don't have to always be connected to a master to do things. States. States are, and this is like going to sound almost too easy, but states are what you use to determine the state of a machine. Easy? Okay, cool. Yeah. Yeah. So yeah, there's like 50 different states that you can have. So the state of the machine being a configuration, a list of instructions on what Salt should do to that particular machine. Then, so Salt is mainly built of a bunch of different modules and a bunch of different, so each like group of modules performs a different task. And in a little bit, we'll cover like some of the unique modules that we'll go over and what they actually do. And then lastly, we have salt call, which is going to be the command that you run to invoke different salt states and different execution commands. So let's go over those some of those salt modules I was talking about. So we'll cover 4 of these modules in a little bit more detail, and we'll start with grains. So salt grains are used to derive information from the underlying file systems that it's being run on. These are very similar to Puppet's Facts or Chef's Ojai. They're called grains because they give Salt little grains of information about each machine. It makes sense, right? You can see what grains are on your machine and available by just running sudo salt call -- grains. That'll give you a list of all the key value pairs of the grains. And if you want to view just the keys, like what available grains are actually on your machine, and you don't care about seeing what the actual values of them are, you can just do salt call grains.ls. And if you want to, yeah, you could go ahead and just run those. You can try it if you want. Okay, execution modules. Can anybody guess what execution modules do? Yeah?
I cannot guess, but I have a different question.
Sure.
Which directory are the binaries for salt? I'm trying to run salt call and not getting any kind of file.
When you install the package, it should put them in your path. If not, it's opt salt bin. Oh, yeah, good call. Lovely. Okay, yes, execution modules. So they execute actions on the machine. Again, the naming terminology is pretty simple, so it's easy to understand. Salt comes with about 14 different unique macOS specific modules, which is pretty neat. So they've done a lot of work with macOS already. And a few of them that are available. One is Mac Service, which controls launch daemons. There's also the Mac Defaults module that, as you can guess, is a wrapper for like the defaults command. And there's also the Mac Package Util module, which allows you to install packages and inspect those packages if you want. And there are dozens of other cross-platform modules that also work on macOS. So let's take a look at using some of those execution modules. So for instance, if you want to list all the available launch daemon services, you can just do salt call service.list. And then if you, let's say you wanted to get the software update catalog URL from the machine, you could just run salt call software update.get catalog. Let's take a brief look at like the syntax that's here. So software update is going to be the name of the module. And then after that, after the period, is the name of the function that's in that module that you want to call. And if there are any parameters to that, you just pass them later, which in this case would just be if you want to set that URL to a suite URL. So state modules. I wonder what these could possibly be used for. So state modules are responsible for the configuration management portion. They take the instructions that you've given Salt, and they're responsible for making sure that it's in the correct state that you want. So packages are installed, services are running, files are there, all that kind of stuff. State modules are the idempotent portion of this, which is basically a fancy DevOps word for not running everything all of the time if you don't need to. So it checks to see if something is in a particular manner or in a particular way. And then if it's the way it should be, runs it again. You're smiling, Alistair. Yeah. So I actually, this morning I had a really good idea, or at least I thought it was, to do DevOps bingo. So everybody would have gotten a nice little bingo card, and then if I said a particular DevOps-y or configuration management-y fancy word, then you get to check off the bingo, and then somebody wins a prize at the end. Fortunately, not enough time to make that and print out 70 copies or so. But anywho, so back to the state modules. State modules are actually all multi-platform, a majority of them. So a single state module is actually responsible for the same type of configuration on multiple platforms because they all pretty much have the same idea and the same concept. They just work different ways on different platforms. The last one we'll cover is renderer modules. So the only thing that Salt really cares about to define the state of a machine is it's just a Python dictionary. So renderers take any type of data that you have, or like a data set that you want, and then it just converts it into a Python dictionary. So if you want, you can write states for Salt in YAML with Jinja. You could write it in pure Python if you wanted. You could write it in JSON or even HJSON. Does anybody know what HJSON is? I did not know that until like going over renderer modules. Nobody? It is actually, it's like a YAML JSON hybrid. It basically allows you to put comments in JSON, and it's a little bit more human readable. I found it fascinating, and it's actually kind of cool. But yeah, so if you wanted to define information in Salt in HJSON, you could. So you're not bound to one specific way of doing anything. Okay, so let's actually write a state, since we've talked about it about 75 times now. So we're going to go over the YAML version of Salt's state syntax, which is how most of the examples are in the documentation. If you couldn't tell, this probably isn't going to run anything. This is just the template of how it's organized. So we're going to change this into a state that will manage a file with certain contents in that file. So the first one here is ID. The ID is a unique identifier to, in a human readable way, describe what you're going to do in the state or what it's doing. In this case, we're just going to make a file. So since Salt states are just a bunch of Python modules, we need to be specific about which ones we want to use. Seems pretty reasonable. So if we want to manage a file, let's use the file module. So after that, we should specify which function inside the file module we want to use. And in this case, we want to manage a file. So we'll use the managed function inside of it. So next, we're going to, so we need to tell Salt where we want the file. Otherwise, it has no idea where it wants to put it or what you want to do with it. In this particular state, that's going to be covered under the name parameter. And this will be the location of the file that you want to manage as an absolute path. So in this scenario, we'll just make a file in temp salt psu and a file to manage, because I couldn't think of anything clever to put there. Fluffy unicorn bunnies, maybe? I don't. Yeah. So functions often have multiple arguments to control different ways of doing or like controlling that particular function. So by default, Salt will not make a directory for you if you don't want it to, this parameter is false by default, and I doubt anybody actually has temp salt PSU on their machine. So you need to tell salt that if there is a directory missing, create that directory as well so we can resolve the entire path. And then for funsies, we'll go ahead and put some stuff in the file because, you know, what's the point of just a blank file sometimes? So one of the other parameters that are available is the contents parameter. And we'll go over showing a list of, like providing a list to a parameter. So for the contents, in the file, on the first line, so each item in the list is a line of the file. So the first one we'll do, we made a file with this string on the first line. Yay, that was pretty easy, right? On the second line. Yay, super easy. So I bet you're wondering, cool, we just made that sweet file. Probably nobody is, or we made that awesome state file. How do we run it? How do we do that? So it's pretty simple. If you've done the instructions so far, you can just run salt call state.apply, which is saying, give me the state execution module, and I want to run the apply function that's in there, which then runs other states. So this particular one is in the states files file.example, or file-example. And if you run that, you should see output similar to this. So by default, salt doesn't really give you any output during the run. It tries to keep it quiet, and then at the end, it will give you a summary of what's happened. So in this particular run, the output will give you on the top line the ID, which is that unique identifier. In this case, it was make a file. And then it'll tell you the function that was used. We used the file.managed function. And then the name, or in this case, the path to where the file was. That'll be in the name. And as you can see, it was true. It worked. And then each state has a comment, so you know what actually happened. And in this case, that file was updated and or created. You can see some started and duration times, then also the changes that took place. So, which in this case, we made a new file. And our total summary. So as you can imagine, when you have more and more states, these numbers grow. So in this particular scenario, we ran one successful state, and there were one set of changes. And it took all of 22 milliseconds to run. I would do it live, but live demos are not my forte. So for funsies, I changed the second line of the file from that was pretty hard, or from that was pretty easy to that was pretty hard. I ran salt again, and it's telling me that the diff that it did after it successfully ran was it changed that second line back to what it should be, which was that was pretty easy. I mean, it was pretty easy. Is anybody actually doing it live? No? Yes, no, maybe so, not working?
I would like to play along, but I think I missed the portion where the master was set up. It keeps looking for the master on my.
Oh,
sorry. I would like to play along, but I'm missing the portion where it does the masterless setup.
yeah, so if you copy the minion file over, and then you restart the daemon, it should be in masterless already. If not, you can just add -- local, and that'll for sure specify to run locally. So, as I'm sure you know, if you manage more than like 2 machines, Each machine is probably a little bit unique, and you need to apply different things to different machines. So how Salt does that is you can specify in what's known as the top file, and this gives it a bit of some instructions on which machines to apply them to. So let's take a look at a super simple top file. So in this top file, it's going to use the base environment, which is here at the top. You can specify multiple environments, however many you want. You could do base, dev, production, wherever you want. This particular, in this base environment, we're going to specify that all machines get the next particular set of configurations. So any machine that has this top file run on it will get every single state that we specify below, which in this case would be monkey, OS query, and crypt. So this is a little bit more of a advanced top file. So as you can see, we have just our base environment. And this particular set will only run on a macOS device. And how it's doing this is it's basing it off of a grain. So as we talked about earlier, grains they provide different information about the machine. And one of those grains is the OS type. And in this case, it's macOS. So it'll then run in if we had a full setup of directories in different states. In this particular case, it would run the state's Mac file, or state. So if a particular minion was configured for a dev environment, and the OS release version is 10.12, which is also being matched off the grain, then that machine could get all the states that are in the 10.12 directory. Then if we had a production environment set up, you can do some conditional logic. So if the OS is a Mac and the host name is Baz of some sort, then these states will be applied. So, but let's say we had the same top file but no environments. So Salt doesn't just stop at the first one. So say we had a Mac that was on 10.12, it would run both of these. But if that Mac that was on 10.12 had a host name that has Baz in the name, then it would get all of the above states. Okay, makes sense. Anybody have any questions about that particular top file? No? Cool. Yeah, sure. Up here. Wait for the mic if you don't mind. Thanks.
Are you providing the name for those states themselves, or are those built in the salts?
No, those are all provided. So in the like the SRV directory that we made earlier, it'll look inside of that for these. There would be a directory called states, and then subsequent directories underneath them. I'm going to actually go a little bit deeper into this a little bit later, but I just wanted to touch at a high level right now.
Okay, thanks.
Does that work? Cool. All right, so let's look at some more advanced states, because just writing a single file with like a couple lines inside of it is probably not what you're going to be doing to a lot of machines, possibly, but we'll look at some more advanced tactics here. So for advanced states, the first thing we'll look at is specifying multiple states under the same ID. Then we're going to take a look at requisites. So what requisites are they are a way in Salt to connect different states and perform certain actions when certain things are true. Then we're going to look at doing some templating in Jinja. If you've ever used Jinja, then this will be pretty easy. If not, it's still pretty simple. And then we're also going to take a look at different renderers. And in this case, we'll take a look at how you would make a state that's using the Python renderer. Anybody want to take a guess at what this state does? No? Yeah, sure. So this particular state, we're going to say that it's actually monitoring the application usage launch daemon that comes with Monkey. So we want to make sure that a file exists on the system. And in this case, we also want to make sure that a service is also running, which would be a launch daemon. So for the top piece, we want to make sure that the file at library launch daemons com.googlecode.monkey.appUsageMonitor is there. And the source of that, where you see salt : / is actually saying make sure that the file that we have in our repo, which in this case would come out to wherever we have it. When I was doing this locally, it was in my downloads folder for everything else. So it'll take that file and make sure that it is at library launch daemons. Make sure that the permissions are root and wheel, and with the executable of 644, or the mod permissions. This piece of the state will make sure that the service is running. So Salt will use the same name for multiple platforms. So some configuration management tools might have this labeled as like launch daemons or launchd or launchctl. Salt tries to bundle it all underneath one name, so you can run it on multiple platforms and you don't have to specify multiple things. So in this case, launch daemons are services, and we want to ensure that that launch daemon is running. And we're going to check that com.googlecode.monkey.appUsageMonitor is running. And you're probably wondering, okay, how does it know that name? Or how do you know which name to specify? So if you look at the actual launch daemon plist, you can use the label key if you want. You can also specify the full path to where it is, or just the file name. So now let's take a look at this fun little guy called watch. This is a requisite. So the service module in Salt, if you specify a watch requisite, it will, and if any of the requisites are true, it'll restart the service. And to specify that, you specify the module that it needs to watch, which in this case is the file module. And then you need to specify the name of the other state you want to manage, which is matched here. You can also specify the unique ID if you want to, instead of the name, which we could then put just monkey app usage launch daemon. So if any of those other states get modified in any fashion, Salt will automatically unload and reload the app usage monitor launch daemon. So let's take a peek at another requisite. This one's called OnChanges. So in this state, we're going to make sure that a line is appended at the end of a file. And the file that we want to make sure that we have a line at the end of is etc asl com.apple.install. And we want that particular string of text at the bottom of the file. So this is actually a state for OS query. And this will make sure that the Apple install logs get also sent to syslog so OS query can gather them up. Big shout out to the Airbnb security team for finding this and putting this up. So this is a state to manage that. So we have this, this other state declaration in this ID called command.run. So command.run by default will not actually run anything unless there's an action to cause it to run. But if that action that would cause it to run is true, it would run this command, which is disabling the syslog and turning it back on. But the only way it would do that is if, again, the particular state file, which in this case, whoops, too far, is the etc asl com.apple.install file. So if that's modified, then it'll run this command. So now let's take a peek at using Jinja in states. Has anybody actually used Jinja? It's more of like a web development templating framework. Shay Craig's probably like, it's great. More Jinja. So that's the default templating that Salt uses. So in this state, let's make a file using Jinja. So Jinja can specify grains if you want to. So in the top file, we had like different OS versions. But say you don't want to like make 75,000 directories, you can make a single state and then in that specify different objects if you want to, based on different conditionals. Instead of making the same state 75 times, you can make it once and put a little templating inside. So for this particular one, if the OS release version has 13 in it, so a 1013 machine, it'll make this file. But if it's on a 1012 machine, it'll make this file. And if it's not on 1012 or 1013, then it'll make the file that we don't know what we're on. We could actually make a file with the actual OS version that we have, but this is what we decided to go with. So this is a local example of that requisite of OnChanges. So if in this particular time you need to specify the ID because you don't actually know which name is going to be there. So when you specify the ID, if anything, any of the files that are modified, it'll run that command. So say we wanted to do that. You can run it this way. States files file.jinja with state.apply. And this particular one was run on a 1013 machine. So as you can see, the file macOS _13 file was created. But after that, it saw that the file was created. So Salt was like, oh, you told me to run this particular command after something was modified. In which this case, we just ran the command echo. We made a file, so we should run this command. And here's the output from that command being run. So it captures the process ID that was spun up to run this command. The return code was 0. There was no standard error output. And the standard output was, we made a file, so we should run this command. Shay Craig told me I should do this with cowsay, which is actually kind of funny, but that was more slides to be made, so I decided not to. And the normal output with the summary. So let's say you are one of the people that 100% everything must be in code. Then if that's the case, the Python renderer is probably for you. You could write a state file with something like this. Let's get a little bit of a closer look. To specify which renderer Salt should use, in this particular case, just shebang pie. And then all that's needed, or the only thing Salt will check for in this particular Python state renderer is a function called run. So, like I mentioned earlier, the only thing Salt really needs is just a Python dictionary. So let's make a dictionary here that we can add different state configs to. And let's say we want to make all these files, foo, bar, baz, bat, ball, banana. Salt would loop through this list, and then it would make a state file based on the name of the file, and it would add inside that file the name of the file. So we made a file foo, or we made a file bar that with this string on the first line. And then just return that dictionary, and Salt's pretty happy. So, unfortunately, the folks that wrote Salt weren't capable of thinking of everything that you could possibly want to do. So sometimes you'll need to write your own Python modules or functions. we're going to show you how to write just a simple execution module in this case, and how to call it, or test it in this case. So this is a super simple execution module. As you can see at the top, we're just importing a few different Python libraries and setting up the logger. Logging's good, so in case anything breaks, getting logs is always good. So how Salt decides which modules it should use is all done with the virtual function and then the virtual name. So if you have a execution module called Batman and Robin, and you really wanted to confuse people, you could tell Salt that the actual name that people need to use for that particular module is called foo. So before Salt performs any actions, it goes through and it compiles all of the available execution modules and what's available. So in this particular case, if this module was run on a Windows machine, Salt would return false that module.foo is only available on Mac OS if you tried to run it. But since we're on a Darwin machine, it'll return foo. So Salt now knows that this module is named foo. And we have one function in here called bar that takes the parameter baz. And what this will do is it will run another Salt execution module called command.run, which what we saw earlier in some states. And then it'll pass the parameter baz to that other module. I mean, this is a little bit redundant because you could probably just call the command.run, but as a super simple overview, then we could go ahead and just run that locally. So you could do Salt call foo.bar with the parameter echo, we ran a command, and your output would be, we ran a command. Super easy, if you know a little bit of Python. So let's take a quick look at also running a state module. So this would be used to make sure that a certain custom object that you want is in a particular state. And in this repo, it's in salt psu _ states is where you would put any of the extra state modules you want. So while I was preparing for this talk and writing it up, I was looking at all the different Mac modules, and I stumbled across the software update module. So this is an execution module. So if you tell Salt to do this, it'll just run it every time. Execution modules are not idempotent. They'll normally just run every single time. That's the idea behind it, is when you run an execution module, you want to execute that no matter what. But I was just like, I don't think there's an actual state module for this that would be idempotent. So we don't run something every single time Salt runs. It's not very efficient. So I looked at the different spots for different modules. Like there is no multi-platform software update module. So I was just like, okay, let's write one real quick. And here it is. So let's take a peek at the import. Oh no, wait, you guys can't see that? Hey Siri, enhance. Oh hey, Thank you. That's the first time you've ever worked. So again, we're importing and setting up the logger, specifying the virtual name. Again, like the previous execution module, this is literally only on Mac OS. And I wanted to write a state function that's called setCatalog. And what I wanted that to do was make sure that the software update URL catalog is always set to one particular thing. And it has a simple parameter, which is name. All states have a name parameter. And in this case, it'll be the URL of the software update catalog you wish to set, or if you pass it default, it'll set it back to the default catalog for whatever that particular machine is. So when we saw all that output from previous states, they all had like a name, a result, what changes were made, and a comment for what was run in that particular case. So we can easily set all that return values up here in just this simple dictionary. So before we set the catalog, we should check to see what the actual catalog is. So in this case, we're telling Salt to run the actual execution module, software update.getCatalog, and we're going to store that as the old catalog value. Then we're going to check to see if the old catalog value name matches the name we want it to be. If it does, then we're good. It's in the state we want it to be. We don't need to run anything else. So we'll set the comment to the software up catalog is already set correctly, and then we'll return the information. But let's say it's not. We need to change it to what we want. And in this case, we're going to use the software update.setCatalog function and pass it the name, which would then run that execution module. And with that particular execution module, it'll check itself to see if it actually ran correctly. Some don't. But for this one, so if it didn't run correctly, then setCat would be false. And then we know that the result of this state run is false. And we can set the comment that we failed to set the software update catalog. But if it's true, then we can say we set it correctly. And then you know how it did the diff at the end? For the changes, so we would say, well, the old catalog was set to this, and now the new catalog is set to whatever the new one was. So if you were at MacAdmins, Bryson gave a really good talk on Python docstrings. So this is how Salt documentation works. So in every single function and at the state, you can write a big docstring that tells you how to use your custom state. And these are examples of some of the YAMLs on how to set it. I also made this state run or make sure that the schedule for Apple software update is always on. And that's how you would set up a state to use either of those. So just software update.setCatalog. We want to make sure it's the default catalog. And then we want to turn on them updates. So software update.schedule with the name on. So anybody have any questions around writing custom state modules or execution modules? Nope. Okie dokie. I'm assuming everybody knows what's going on, right? Yes? Yeah. It's fun once you get into it, I promise. Now I sound like one of my friends trying to explain a board game that takes like 7 hours to play. It's going to be fun, I promise. So SALT has what's known as a high state. And a high state is whenever SALT looks at that top file, and it goes through the entire SALT repo that you have and decides which all states it should run. So when we run a high state with this particular repo setup, it'll first look in this top.sls, which is what we looked at earlier, which in this case, we want to, on just macOS machines, matched off the grain, we want to run everything that's in the states directory. So let's take a look at the states directory. It'll look inside the states directory for an init file, which then you can specify other states in. So you don't have to, in the top file, list out 85 different states. You can just slowly work your way down the directory. Inside the init file, there's an include. So we want to say, in this directory, we want to include all the file states and all the software update states. So if we go back and look at that directory, it'll then look inside the files directory and the software updates directory for their individual init files, which we'll just take a look at the files init file. And as you can see, we want to run the directory, the file example, the file Jinja, and the file pi states. And it'll actually do it in that particular order. So if you want to specify an order of operations, you can do them in the init files. And then if you ever want to run a high state, just SALT call state.highstate. So by default, the SALT minion won't actually constantly be looking for the configuration and where you have a high state or where you have a top file. You need to tell the minion how often you want to run a high state. And how you do that is you can write a schedule state. And whatever you're using to install SALT on that particular machine, you can have it run this state, which will then set up the rest of the high state for you. Which, with this, will run it every 60 minutes. And you can only be running, you can tell it you're only allowed to run one high state at a time. You can have schedules available, but not active. So with the enabled key, we want to make sure, yes, that the high state is running. And then we're going to use the returner. So what a returner is a different module. So there's multiple types of returner. This specific one, we want to say take all that output and return it as a JSON file and put it in the default directory for that returner. So we can look at it later if we wanted to. And then run it on a splay of 600 seconds, so not every particular hour, but with a splay of a couple minutes in between. So at Square, we actually run a masterless setup. So we don't have a SALT master. So you're probably thinking, how do you continuously get all the files that you want with the particular changes on the machine if the minion isn't talking to a master to get the files and do all that fun stuff? Wait for it. So SALT actually has a archive state where you can specify where you want the particular where you want to pull the particular archive from and extract it. So in this case, we have a tarball sitting on rounded dot corners in the salt directory there with our tarball. And then we also gather a hash of that particular tarball, and salt will check the hash after it's done downloading against the tarball that it's pulled down, make sure that it matches. If it does, then it'll extract it to the particular directory, which in this case is srv salt. And then all the other parameters are, so for instance, if it'll cache the last known hash, if the last known hash matches the current hash, it's done. It won't even bother downloading the file because it knows what it wants. And then say something else is in that particular directory, the force key says forcibly extract this archive to that particular directory no matter what's happening, so use that with caution. Keep source says cache the old tarball around, keep it around so you can compare it later. And then clean makes sure to look through every single file to make sure that it's the way it should be. And then we're also setting some directory permissions there. So with this, in the high state, salt will pull down a new tarball and extract it. And then on the next run, it'll pick up the changes and apply them. And that's pretty much it. Anybody have any questions about this particular bit? Yes, no, maybe so? Oh, come on, not one? So before we go, oh, sorry, I totally missed you.
There you go. You may have covered this, but what do you use for reporting, like to know that things have actually run from a sort of centralized viewpoint?
So, great question.
Don't think you touched
I
on that?
I thought about throwing this in here, but then I was like a little bit concerned about time. So we have a launch daemon that looks for the modification of where this raw JSON file gets laid down, which would be back here. So the default for that is etc salt log, or no, sorry, var log salt, and then I think it's minion or either returner. So every single time it'll put a new JSON line in that file. And we configured, we rewrote the SAL reporter if you use Monkey and you're familiar with SAL. So whenever the SAL report script runs, it gathers all the salt IDs and actually puts them in SAL. So when you look at a particular machine in SAL, you can see every single application that Monkey's installed on it, and then every single state ID. And if there's any problems, it looks for all the logs and any errors, and it'll mix them in with the Monkey logs specified as salt logs. It's actually pretty neat. So hopefully tonight, I'll see what Shay Craig's doing. But what I actually want to do is you can write custom returners. I want to write a custom SAL returner so you don't have to do the extra bit. So every single time salt runs a high state, it just immediately takes the information and just sends it directly to SAL. All built in, and that could work on multiple platforms too. So, looking at you, buddy. Yeah. Yeah, any other questions? How boring was this? Did anybody learn anything? Maybe? Cool. That's good. So anyway, before we go, otherwise, what's the point of doing all this? So a good buddy of mine, I don't know if you saw Graham's talk yesterday, at the end, He mentioned about how recently he got testicular cancer and how he was lucky enough to beat it. And so I figured we'd team up and try to raise some money for the Movember Foundation. So if you enjoyed any of this or any of the code that I write out there or any of the projects, instead of buying us a beer, donate if you could. Be great. And I guess that's all the Q&A because nobody else had any questions. So, oh, sure, yeah.
All right, so if you were using a master and the clients, does the master ever reach out to the clients, or are the clients just reaching back to the master always?
So, this is actually like one of the really powerful things about Salt is if you are using a master, it has a constant when it's on the internet. Protocol, it's called 0MQ, which is pretty fast, reliable, and that's how it maintains a constant connection. So on the master, you could run like one of those execution modules and say, run this on every single machine that I have right now. Super powerful, pretty dangerous. I didn't even want to like give myself the opportunity to do something like that, but like that's one of the things Salt's really known for is its ability to do something like that is like modify 10,000 servers at any given one point with just one line in the terminal on your Salt master. So that's why we went with masterless, so nobody can accidentally do something like that. Yeah, go ahead and ask the question again if you could, thanks.
What would be the effect on the network? Would it be staggered at all?
So the communication would be very lightweight because it's just, it's not like you're sending a 100 megabyte package to each machine. You could, in that case, it would probably get pretty crazy, but if you're just running a single execution command, but Salt does all the magic. I am nowhere near understanding of how all that magic works. I'd recommend, if you're actually like super curious, I'd recommend the Salt Slack channel, like on the Salt team, and ask in general. They're always super responsive and super friendly, and I'm sure one of the actual main core engineers would love to tell you about how that works. Anybody else? Alistair. Oh, no comments.
Where can we get one of your attractive t-shirts? Did you bring enough for the class?
It's always you. You already got one, dude. You need a new one? Okay. I don't just get them for free to like hand them out. But maybe next year I'll see if I can bring some cool square t-shirts. So yeah, sorry, Alistair. Maybe this one's probably too big for you anyway, so I don't give you a shirt off my back, man. I love you, bro. Anybody else? Cool, thank you so much.